So today we're going to continue to solve more rational equations. The first example that I have for you has two different denominators. We've got x over 3 minus 2x over 5 is equal to 1. And you can see if I've got it written 3 times already because we're going to solve it in 3 different ways or slightly different ways. One thing I'd also like to point out is, of course, it might also be presented a little bit differently too. We'd still handle it exactly the same way, but it's possible that we can clearly see the coefficient, so it might be 1/3 x instead of x divided by 3 minus 2/5 x is equal to 1. So it's really the same question, just formatted in a slightly different way, but we would handle it the same way to solve. So I will just start with what I have anyways. X over 3 minus 2x over 5 is equal to 1. And so if you recall what we were doing last class, if I don't like this divide by 3, then our inverse option is going to be to multiply by 3. So I would need to multiply the whole left side by 3 and therefore multiply the whole right side by 3. When I multiply the left side by 3, I'm essentially going to distribute that 3 into both terms. So I'm just going to write it twice, and remembering it's multiplying by 3 over 1, and in this case 3 over 3 is the same as 1 over 1, so we're left with simply x, then minus, and nothing reduces here, so now we've got 6x over 5 is equal to 3, so one denominator down, one more to go, and here we've got divide by 5, so to counter the divide by 5, we'll multiply the whole left side by 5, and therefore we'll also multiply the whole right side by 5. Once again, we distribute that 5 into both terms, so I'm just going to write that twice. And so 5 times x is simply 5x, and then 5 over 5 in this case is the same as 1 over 1, so 5x minus 6x is equal to 15. And then in this particular case, we will do our 5x minus 6x, which is negative x, is equal to 15, and then multiply both sides or divide both sides by negative 1, in which case x is equal to negative 15. Fantastic. So the next way that we can go through it is rather than taking those 2 steps to multiply by 3, clean it up, then multiply by 5, some people like to do both at the same time. So they say, hey, I know that I want to get rid of the divide by 3, so I'm going to multiply both the left side and the right side by 3. I also know I want to get rid of this divide by 5, so once again I'll multiply both left side and right side by 5. And now, of course, we all need to distribute that in, so I'm just going to rewrite those brackets. So 5 times 3 on both those terms, and then we know the 3 over the 3 is just 1, the 5 over the 5 is just 1, and that leaves us then with 5x minus 6x is equal to 15, and of course that looks really familiar there, so I don't need to continue with that. Alternatively, as a third choice, so a lot of people then say, well, wait a second, if you're multiplying by 3 and also multiplying by 5, aren't you just multiplying by 15? Well, that's exactly what we're doing. So we could also say, hey, I want to multiply the whole left side by 15 and the whole right side by 15 as well. This 15 will distribute to both So then I'll just rewrite it beside both. And remember, it's 15 over 1 that we're multiplying. And so if we're to switch that around, so instead of 1 times 3, 3 times 1, so we could say, hey, 15 over 3 is the same as 5 over 1. 15 over 5 is the same as 3 over 1. So now we're just looking at 5 times x, and then minus 3 times 2x, also known as 6x, is equal to 15. And once again, we've got the same thing that we had in the other two solutions. So 3 ways to go through that. A fourth way, of course, would be to find a common denominator first and then combine everything and then multiply by 15. Regardless of which way we do it, we should all come out with the same final answer, that x is equal to negative 15. Okay, so let's go on to the next question. It's going to get a little bit more difficult. So in this particular one, we've got 2x plus 3 all over 3 is equal to x plus 7 all over 2 plus 1. And so once again, we've got a couple of different denominators. The difference in this particular case, though, is rather than just having the 2x over the 3 or the 3 over 3, we've got all of 2x plus 3 all over the 3. So again, we've got some options. We could find the common denominator. That works. But myself personally, I find it the easiest to try to get rid of the fractions to begin with. Typically speaking, we make fewer mistakes in that way. So if we go through and multiply the whole left side by 3, and on this we'll multiply the whole right side by 3. Looking ahead, we've also got a denominator 2, so let's also multiply by the 2. And for some of you guys, you may have decided to just multiply everything by 6. So on the left side, the 3 over the 3 is simply 1. So if I was to clean that up, I would be writing 2 times 2x plus 3. And that is equal to, and on the right side, the 3 and the 2 have to distribute into both terms. So once again, I'm just going to rewrite that, add some brackets in and show that I'm multiplying both terms by the 2 and the 3. And in this case, the 2 over the 2 is just 1, in which case we have 3 times x plus 7 plus 2 times 3 times 1, which is obviously just 6. And now this looks a lot more familiar, and we can go ahead and complete that. So if you wanted to hit pause and then try working through that on your own, and then coming back and seeing what I have, then that would be great. We can compare notes. Even better, if you want to do a left side, right side check, then you can see that your answer is correct as well. Okay, so if you tried it on your own, then perhaps what you did was you distributed that 2. So if I've got 2 groups of 2x plus 3, that's the same as having 4x plus 6 is equal to 3 times x plus 7, or 3 groups of x plus 7 means we have 3x plus 21, and then plus the 6. And we're not multiplying the 3 times the 6 because, of course, the 6 is not within the brackets. And then let's clean up that right side, 21 plus 6. So we've got 4x plus 6 is equal to 3x plus 27. And then we'll decide which side we want the x's on. So let's say we'll move the x's on to the left side. So we'll subtract 3x from both sides. That leaves us with 1x, which is awfully nice. X plus 6 is equal to 27. And that means all of our units will go onto the right side. So we'll subtract 6 from each side, and That gives us that x is equal to 21. So hopefully you got that as well. And let's just do a quick left side, right side check. So on our left side, we had 2x plus 3 all divided by 3. If we substitute in our answer of 21, then we've got 2 times 21 plus 3, and that's all going to be divided by 3. So 2 times 21 is 42. Add 3 divided by 3. That's the same as having 45 divided by 3, and 45 divided by 3 is 15. Well, we don't know if we're right just yet because the right side, we have to figure out what that equals to. So if we have x plus 7 over 2, and that's going to be added to 1, so that's then 21 was our answer for x, so 21 plus 7 divided by 2 plus 1, or 28 divided by 2 plus 1, and that's 14 plus 1. Oh, look at here. 14 plus 1, 15. So our left side equals the right side, and we are happy. Great, so that confirms that our solution of 21 is correct. Okay, so probably the most difficult question that you will see is going to be one that is similar to what we just saw above, where you've got two terms, a 2x minus 3 over a single number, and x plus 5 over a single number of 4. But the big difference, because I know some of you were thinking about that last question, well, that wasn't maybe so bad. But the biggest thing is this subtraction symbol right there, and that is going to confuse and catch a lot of people, so be careful. As soon as you see the subtraction, those warning lights should be going off right away. So let's take a look. So here we've got divide by 6, divide by 4, divide by 3. So certainly you could multiply everything by 6 and by 4 and by 3. That will work. Your numbers end up being a little bit larger. Another way to think about this is what would be a common multiple of 6, 4, and 3, meaning what number is divisible by 6, 4, and 3, and if you said 12, then you would be correct. So let's then multiply the whole left side by 12, and then we'll multiply also the whole right side by 12. And so I'm just going to actually rewrite this. So we've got 12 times 2x minus 3. Oops, I'll change a color there just to help you guys see it a little bit better perhaps. So 2x minus 3 over 6. And then minus 12 again times, and maybe I'll just write all of these down just to save us a little bit of time there. And we'll fill that in. So minus 12 times x plus 5 over 4. And then minus 12 times 1 is equal to 12 times x over 3. Now, one of the things that I want you to pay attention to is also where I'm writing the 12. I'm not writing it down here, 12 times this, 12 times this, because guess what your brain sees when you write it right at the bottom like that? It's seeing 12 times 6, and you are definitely not multiplying 12 times 6. You're not multiplying 12 times 4 at all. So technically speaking, even though you're saying, hey, I'm multiplying that first term by 12, your brain is seeing something else. So by writing it up high, or even by writing in 12 over 1, hey, I'm multiplying by 12 over 1, then it helps your brain to see, hey, if I multiplied that in I could also switch around the 1 and the 6, because 1 times 6 is the same as 6 times 1, and 12 over 6 is the same as 2 over 1. Similarly, 12 over 4 is the same as 3 over 1, and 12 over 3 is the same as 4 over 1. And so when we clean that up, it makes it a lot more doable. 2 times 2x minus 3 times x plus 5 minus 12 times 1, which is of course 12, is equal to 4x. And look at that, all of the fractions have seemingly gone away. So again, remembering that, how is it that I can just randomly cross that out? That goes back to multiplying fractions. And remember, we've done quite a few examples like this. So if I was to give you, let's say, 8 over 9 times, and this is a total aside, but 8 over 9 times, we'll go with 15 over 16. So I really don't want to figure out what 9 times 16 is or 8 times 15, but what I know is that 8 times 15 is really the same as 15 times 8. So if I was to switch around the numerators there and had 15 over 9, times 8 over 16, that's actually going to give me the same product, because multiplying fractions, we multiply across the top, we multiply across the bottom. But now when I look at this, we've got 15 over 9, both divisible by 3, so I'm dividing top and bottom by 3, so that's the same as 5/3, and 8/16 is of course 1/2. Now when I multiply across, we're simply looking at 5/6 as our simplified fraction. So that then is essentially what we're doing when we've got that 12 over 1 times 2x minus 3 over 6, is I'm swapping around that 1 and that 6, because multiplying 1 times 6, 6 times 1, so 12 over 6 times 2x minus 3 over 1, and 12 over 6 is the same as 2, so that's why we've got 2 times 2x minus 3, and I've got that right there then. Okay, so I'm just going to erase this piece then, and we're going to continue solving our equation there. So distributing in that 2 would give us 4x minus 6, and this is the part where the subtraction gets tricky, because we want to think of it as we're distributing in -3. So we've got 4x minus 6 minus 3x minus 15. So -3 times +5 is -15 minus 12 is equal to 4x. So before we go anywhere and moving things left or right, let's clean up that whole left side there. So I've got 4x's minus 3x's. That's just going to leave me with 1x. And then we also have minus 6 minus 15, so it's getting more negative, so that's negative 21, minus 12, and that's more negative, so negative 21 minus 12 is negative 33. And that equals to 4x. So with x's on both sides, I'll move the x's onto the right side. So therefore, I will subtract x, or add a negative x to each side. That then leaves me with negative 33 is equal to 3x. And then we will divide both sides by 3, in which case 1x is then equal to negative 11. Awesome. So our check for this one, our verification, is going to go back to our original question, because there's a lot going on in here, so I really want to make sure that I'm not just checking with this nice clean one, or definitely not with this x minus 33 equals 4x. I need to go back to the very, very, very beginning. So our left side was 2x minus 3 over 6 minus x plus 5 over 4 minus 1. So let's see what happens when we substitute in our answer, which was negative 11. So 2 times negative 11 minus 3 over 6 minus negative 11 plus 5 over 4 minus 1. So then that would give us negative 22 minus 3, or negative 25 over 6, minus negative 11 plus 5 is negative 6 over 4, and minus 1. And I know the negative 6 over 4 can be simplified to 3 halves. So we've got the negative 25 over 6. And I also know that minus and negative is going to be the same as plus. So plus 3 halves then, and then minus 1. Now that we're dealing with fractions, I'm going to need a common denominator. So common denominator would be 6. So then we'll multiply top and bottom by 3 here, top and bottom by 6. So negative 25, 6, plus 9, 6, minus 6, 6. And since we have the common denominator, I can keep that denominator, combine the numerators. So negative 25 plus 9 is going to make it negative 30, oh, sorry, no, negative 16 over 6. And then minus 6 over 6 is then, again, keep that denominator the same, negative 16, and take away 6 gives me negative 22, and that can be reduced, simplified, to negative 11 over 3. Okay, so it's not super pretty, but let's take a look at that right side. On the right side, it was simply, our original was simply just x over 3. And substitute in x is negative 11, so negative 11 over 3. And look at that, left side equals right side. Fantastic. So that means our solution of x equals negative 11 is correct. So that's some examples. There are some examples for you on how we can go through to get rid of those fractions. Of course, an option is always to find a common denominator and to combine the fractions from there. Those of you who are comfortable with fractions might still want to do it that way. Even though I can say myself, I'm very comfortable with fractions. However, I know that I'm slower when I work with fractions, and I might be more prone to making mistakes with fractions than I would be with integers. So I personally like to kind of get rid of those denominators by doing the opposite. So denominators represent division. So by multiplying, we can essentially get rid of those denominators. So be careful, do the math correctly. Don't just assume, oh yeah, well, I just cancel it out. Think it through as you're going through it. Okay, if you have further questions, be sure and ask me or one of your other teachers. Thank you.